All right, in this last video on applications of exponential functions, what we're going to do is we're going to show how we can take a discrete growth formula and convert it into a continuous growth formula. Okay. So what we're going to do is, this says write the exponential function 7 to the times 1.24 to the t power in the form y equals a times e to the power of kt. Okay, so this is a continuous form because it has e. Now the thing we're really trying to solve for here is we're trying to identify k, and the t is going to remain a t and the e is going to remain an e, but the a is actually the same a as in our discrete formula. A is just the starting value, and since over here the starting value is 7, this a is going to simply become a 7. Okay, and so this is going to be 7, so we know the continuous function is going to be y equals 7e, and then it's got to be to the power of some rate, which we're going to call k, and then it's going to be to the t power. So really all we're trying to do in this procedure is solve for k, and there's actually a really easy way to solve for k. So we know that in the discrete formula, we call this the base of the t, the base of the exponent, we call that b, right? So b is 1.24, and that is what we call the growth factor. And it includes r, because b is 1 plus r. So here r is 0.24, okay? So what we're going to do is, the way that we find the growth rate r for a continuous function is we basically just do the natural log of b, okay? So all you do is the natural log of b, and we get the r in a continuous function, okay? And you might actually have interpreted this previously in all the times that we were solving the exponential functions, where in the denominator we would either have the natural log of b, or we would have the rate for a continuous function. So when this says what is the growth rate r, basically we just do the natural log of b, which is the natural log of 1.24, okay? And so now we'll go over to the calculator and we'll just do the natural log of 1.24 and execute, and we get 0.215. And so E is r is 0.215. Now that's rounded, okay? After the 5 is a 1, that's why we left it as a 5. And so in this case, what we would say is, if we're asked, well, what is k? That means that k is equal to 0.215. And our continuous function then is going to be y equals 7e to the 0.215 t. Okay, so if this discrete growth function was a continuous function, then this is what it would be. You just take the natural log of b. So we're going to finish up with this example. It says a population P of t in thousands in year t increases exponentially at a continuous rate. Okay? Now suppose that P of 5 is equal to 20 and P of 24 is equal to 37. That means that at time 5, the population is 20,000. And at time 24, the population is 37,000. Now, we know how to do this as a discrete formula, but we don't know how to do it as a continuous growth rate formula. So what we're going to do is, the first thing we're going to do is we're going to find the discrete formula. And this goes back to lesson 21, okay, where we were given 2 points and we were finding A and B. Okay, so you can look back at, it might have been lesson 19, but I think it was 21, okay? All right, so the first thing we're going to do is we're going to set up 2 of them. So we know that P of 5 is 20, so that means 20 is equal to A times B, A, B, to the power of time, which in this case is 5, AB to the 5th. Now we're going to do 37 is the ending value, is equal to AB to the power of time 24. I hope this looks familiar to you. We've done this before, okay? So the first thing we're going to do is we're going to take the earlier one, the one with the smaller t, and we're going to solve for A. And if we divide by B over 5 from both sides, we get A equals 20 divided by B over 5. So A equals 20 divided by B to the 5th power. B to the 5th, that's what I meant to say. Now we're going to take this A and we're going to plug it in for A here. And we're going to have 37 is equal to A, which is 20 over B, 5, B to the 5th power, to the power of B to the 24th power, okay? Or sorry, this is A times B to the 24th power. Sorry about that. So this is A times B to the 24th power. Now this can go into the numerator right here. So this is the same thing as 20B to the 24th power over B to the 5th. Well, this can be divided. B to the 24th divided by B to the 5th is B to the power of 24 minus 5. So this is the same thing as 20B to the 19th power. Now, to solve for B to the 19th power, we just divide by 20 here, and we divide 37 by 20. And we wind up with 37 over 20 is equal to B to the 19th power. Well, we just learned how to do this. We know that we can find this B if we raise both sides to the 1 over 19 power. 1 over 19 power. Whoops, this is 19. And so the 1 over 19 and the 19, those will cancel, and we get B is equal to 37 over 20 to the 1 over 19 power, which we can now do in the calculator. Let's see, we're going to do parenthesis, 37 divided by 20, close parenthesis, to the power 1 over 19. Execute, and we get, we got to go all the way over here. Let's see what this is. I'm going to go up here. Let's go up here, and let's go over here. Oh, here we go. It's 1.0329. This 9 will make this 2 a 3. So it's 1.033. Okay? So B is equal to 1.033. Okay? Now if we want to solve for A, we need to do A equals 20 over B to the 5th. So A is going to be equal to 20 over B is 1.033, and that's to the 5th power. And we'll go into the calculator. And so now I'm actually going to use the answer feature here because this is a precise answer. I'm going to use the button, the answer button. Okay, the answer button is down here. And so I'm going to do, let's see, what was it again? 20 over 20 divided by 1.033. But since that's the answer, the previous answer, I'm actually just going to press the answer button, okay? And it's to the power of 5. And so A is equal to 17.0106. This 6 will make this a 1, so it's 17.011. Okay, so A is 17.011. Okay, and actually I think I can just round this to 17, but I guess I'll leave it as 17.011. And so now, here's our formula. P of t is equal to 17.011 times 1.033 to the power of t. Okay? So we found our A and we found our B. And now, it says now convert from a discrete growth model into a continuous. Well, we just have to take the natural log of B, which is 1.033. Natural log of 1.033. Okay, we'll put that in the calculator. The natural log of 1.033 is 0.032. Okay, we can ignore this 4. 0.032. So it's 0.032. And so A is 17.011. So our formula is going to be P of t is equal to 17.011. E, because it's a continuous growth rate formula, 0.032 times t. And this is the final answer.